In this video, I'm going to look at a topic that technically is not on the 2020 AP exam. However, it's one of the core topics in series on AP exams in other years. I think it's something your college courses are going to expect that you've seen. And I think it also gives us some good practice with the ratio test, which is still going to show up on the AP exam. So, maybe this is going a little bit of a step further than what we need to do for the AP exam. But I think in the grand scheme of things, you'll be better off for it. All right, it's called the interval of convergence, or the radius of convergence is sometimes what they ask you to find. And here's the idea. You remember how when we worked with geometric series, for example, if I have a geometric series 1 plus x squared plus x cubed and so on, the common ratio is x. Okay, I'm multiplying by x, multiplying by x, multiplying by x. That series is not always convergent, okay? That geometric series is only convergent when we say x is less than 1, but it's really when x is between -1 and +1, okay? And in fact, a lot of times we'll say the absolute value of x is less than 1. So if we're multiplying by something like a half, if we're multiplying by something like -1/2, this is going to approach a sum. Meanwhile, if I'm making x 10, it's going to go to infinity, okay? That's going to apply to most of the other series that we've talked about. For example, some of the Taylor series approximations, if you remember, the function would look very similar to the function we were trying to model. For example, maybe near 0, if that's what our center was, or if we were modeling the sine function near 1, it would be very closely shaped to the sine function. But as you went out a little bit in each direction, it would be a worse estimate. And if you went out reasonably far, there was just no relation whatsoever between the series and the actual function you were trying to represent. So the idea of the interval of convergence is to try to figure out what values of x will we get a function that converges? Where is this function centered? How far can we go out above x or below x and still get estimates for values of the function that are relatively good, okay? That's really what we're looking at here, okay? So we'll start out with this example here. I've got the series from n equals 1 to infinity of x to the n plus 1 over 3 to the n times n cubed. Okay? Now, you may want to list out a couple of terms here. I don't think it's absolutely necessary, but you can. Be careful here. Remember, the n values are generating the terms. This is going to be a function. It's going to have an x variable. We haven't seen an x variable showing up in a lot of our previous problems, and that can kind of confuse people. But anyway, if you list out a couple terms here just to see if it's anything you recognize, n would be 1, so we'd start out with an x squared. In the denominator, we'd have 3 to the first times 1 cubed. There's going to be x squared over 3. Okay? If n is 2, we're going to end up getting x cubed on top. If n is 3 on the bottom, we're going to get a 27. No, if n is 2, I'm sorry, we're going to get a 9, and we're going to get a 2 cubed, which is 8. 9 times 8 is 72. Okay? And then if n increases by 1 more, we'll get an x to the 4th. That would give us a 3 cubed and a 3 cubed again, actually. So 27 times 27 leaves 729. And anyway, our series continues from there. And if you can see, we're not multiplying by the same thing each time to get from one term to the next. This is not a geometric series. It's not real clear what kind of series it is. You can't just kind of glance at it and see, is it anything that we've talked about? Although the fact that it has exponents in it would make it a really good setup for a ratio test. So what's probably going to happen is this is probably a series that for certain values of x will converge and for other values of x won't converge, okay? So what you do here is you use the ratio test, okay? And remember, the ratio test says that you need the limit as n approaches infinity. You're basically taking a term and dividing by the term that came before it. A term and dividing by the term that came before it. You're essentially trying to see, if you go out far enough, is it approaching the behavior of a geometric series? Is essentially what you're trying to do here. So you take the ratio between the n plus 1 term and the nth term, and you do need to take the absolute value of that, okay? And actually at the end here, you'll see another reason why that comes into play. We briefly talked about absolute convergence. If this series is going to converge, that ratio needs to be less than 1. So what we're really going to be trying to do here is figure out what values of x will make this limit less than 1. That's really what is going to be happening here, okay? So the ratio test setup here is not terrible, okay? Remember, you're doing the limit here as n approaches infinity. We're looking at an n plus 1 term and an n. Make sure you're substituting in for n, not for the x variable, okay? The x variable is just going to stay there, and you'll see how that works out later. That was something I really had a lot of trouble with when I first started doing these. So I'm going to sub n plus 1 into my series up here, okay? If I put n plus 1 in for n here, I'm going to get n plus 1 plus 1, which is x to the n plus 2, okay? In the bottom, I'm going to have an n plus 1 in place of n, so 3 to the n plus 1. And I'm going to have an n plus 1 in place of the n there being cubed, okay? That is the n plus 1 term. So we've got a fraction in the numerator, and then the nth term is also going to be a fraction. It's just the original term, okay? And then technically we're taking the absolute value of that, which doesn't seem important right now, but at the end will be important, okay? So anyway, we're going to continue with this, and we're going to try to simplify this. Remember that when you divide by a fraction, it's the same thing as multiplying by the reciprocal, okay? So I think you'll make your life a lot easier if you simplify this a little bit. Write this as x to the n plus 2 over 3 to the n plus 1 times n plus 1 cubed times the reciprocal of the denominator. So you're going to have a 3 to the n in the top, you're going to have an n cubed in the top. On the bottom, you're going to have an x to the n plus 1. Okay, and you're taking the absolute value of that. Now be careful, we're actually still supposed to be taking the limit of this whole thing. I really need to still have a limit out here. I've heard that they will dock you points on the AP exam if you drop that limit. All right, so anyway, from this point, you need to try to simplify this. Everything's being multiplied across the top, everything's being multiplied across the bottom. So you can really kind of break this up, and I'm going to take this out here and simplify it over here. So we're looking for the limit as n approaches infinity of this product. In the numerator, we're going to have an x to the n plus 2. Okay? In the denominator, we're going to have an x to the n plus 1. Okay? In the numerator, we're going to have a 3 to the n. In the denominator, we're going to have a 3 to the n plus 1. And then we're going to have an n cubed in the numerator, and we're going to have an n plus 1 quantity cubed in the numerator, okay? So that little reorganization here, commutative property, I can change the order around, make things a little bit easier to see as we try to simplify, okay? So again, this is the same thing as the limit as n approaches infinity. I'm going to try to simplify this now. I can divide n plus 1 x's out of the bottom. That's going to knock out all but 1x in the top. Don't lose your absolute value. N 3's will divide out of the top and bottom. That'll leave me with a single 3 in the bottom. Okay? This is n cubed. This is n cubed plus 3n squared plus 3n plus 1, I think, if you FOIL that out. It's a mess. I'm not going to multiply it out. I'm actually going to leave that as n cubed over n plus 1 to the third, okay? For a reason that you'll see in just a second, okay? Now, x, we are not looking at the limit of this as x approaches anything. Just leave x where it is. But take a look. We only have 2 n terms left, okay? In fact, if you want to break this up, this is really x over 3 times n cubed over n plus 1 cubed. Remember, this is going to be a fraction that has an n cubed as the highest power in the numerator. This is going to be a polynomial that has an n cubed as the highest power in the denominator. As n approaches infinity, you've got an n cubed over an n cubed as your 2 dominant terms. This whole thing is just going to approach 1. So this is really the limit. Once you apply the limit, it's just going to leave you with 1 times x over 3. Now, you're wondering, and I've now done the limit. I've now applied the limit. Okay, this goes to 1. We're not touching the x because we're looking at the limit as n approaches infinity. Remember what the ratio test says. It says that the limit of that ratio needs to work out to be less than 1 for your series to be convergent, okay? Now I can take out this absolute value. What it really says is x over 3 needs to be between positive 1 and negative 1. So I'm going to rewrite this just a little bit, okay? And we want to figure out what x is supposed to be between. So I can triple all 3 parts of this. and we will find out that x is between -3 and +3. Now, a little bit of terminology here. This is what is referred to as the interval of convergence. It's a range of x values, okay? And this basically tells us that our function is going to behave like the function that was trying to be modeled. Basically, this is going to be convergent if we're substituting in x values that are between -3 and +3, okay? And again, the more terms we write out, the more accurate this function will end up being, okay? By the way, notice it's going up 3 units from 0, and it's going back 3 units at 0. So we would say this would be a function centered at 0. There's this range of values. You can go 3 above 0, you can go 3 below 0, okay? There's also a term called the radius of convergence. And we would say here that the radius of convergence is 3, okay? In other words, from the center of 0, I can go up 3 or I can go back 3. There's this radius, this range of values. The radius of convergence is half the length of the overall interval, okay? Now, I'm going to add one additional thing onto the video, and this is important if you're taking a real Calc 2 class, and I don't think this is going to be on the AP exam, but I just want to mention this, okay? And again, if you have to not watch the rest of the video, it's not going to kill you for the AP exam, but I still need to say it. Technically, the ratio test is inconclusive if the ratio is 1. It may be convergent, it may not be. Technically, you need to substitute in 3 and -3. The interval may include 3 and -3, or it may include 1 and not the other one, and we don't know until we check those, okay? So technically, once you get done, yes, we know the radius of convergence is 3, and that's whether or not it's equal to 3 on the ends. But technically, if they ask you for the interval, you need to go back and check those values. Okay, now there are a couple of ways you can do this. You can actually just try subbing in, if you've written out a couple of terms, you can try subbing in a couple of terms. Sometimes you'll get like a harmonic, and you'll know, oh, it's going to be divergent. Or sometimes you'll get an alternating harmonic, or you'll get an alternating series with terms that are decreasing to 0, and you'll know, hey, this is going to be convergent for this particular value. So we need to check 3, okay? Now, I wrote these down ahead of time, I think. No, I didn't. Okay, well, anyway, if I stick 3 in here, 3 squared is 9. 9 divided by 3 is 3. Okay, if I stick 3 in here, 3 cubed is 27, 27 over 72. They're both divisible by 9. I think we end up getting 3/8. Okay, we get an 81 here, we get a 729. Let's see, that's 27 squared. That's 3 times 27. So it's 3 over 27, I think, which is 1/9 maybe. Anyway. I don't notably see anything here as I'm just glancing at this that's recognizable. Okay, so sometimes you list out a few terms and you see something. I'm not seeing something here. Another approach you can do is you can go back and you can look at the original expression. Okay, we're really looking at an x value of 3, and you can actually just pop a 3 in this expression, and you can see if that statement would be a convergent or divergent series. So if I had 3 to the n plus 1, in other words, I now know that I want to look at specifically an x value of 3, and then I have 3 to the n in the bottom, and I have an n cubed. Notice all of the 3's except for 1 will cancel. That individual term would be 3 over n. And that would be the series 3 over n moving forward from there. And anyway, oh, I'm sorry, not 3 over n, it would be 3 over n cubed. Okay, and if you notice, that's going to be a convergent p-series. I've got a p-value that's greater than 1. So it will converge for a value of 3. And you may have seen these terms here were dropping, and so maybe it seemed like that was going to be the case. But we can actually say it's equal at 3. Okay, and then you can go back in and you can substitute in -3. And by the way, if you substitute in -3, you're actually going to get an alternating series, because you're going to get, I think it would be +3, negative, what did we say that was, 3/8, and then positive, what was it, 3/27 was 1/9 or something like that. Anyway, this is going to be an alternating series. It is going to be an alternating series with terms that decrease to 0. So it actually will work for -3 as well. Once again, you might be able to pretty easily kind of see that. Again, it might not be real clear what the pattern is and if it's really going to decrease to 0. So you can also substitute -3 back in up here. You would have -3 to the n plus 1 over 3 to the n times n cubed. -3 is the same thing as -1 times 3. So you could write that as -1 to the n plus 1 times 3 to the n plus 1. And you're going to see the same kind of things. You're going to have a -1 to the n plus 1. All of the 3's are going to cancel except for 1. And then you're going to have an n cubed. And this is going to be still a p-series, and it's an alternating p-series. Okay, if the positive p-series approaches a limit, then the alternating one will definitely approach a limit. So anyway, yeah, it's going to be convergent at both of the endpoints as well. Okay, so that's how you can use the ratio test to find what's called the interval of convergence, or sometimes they just ask you to find the radius of convergence.